Uh,
Okay, let's
cool.
close out this. I got your material here. Let me snap that left, snap that right.
Perfect. And then we could start on number 5 is where I left off.
Okay. If you don't mind for a moment, let's back up to 4.
Sure. Yeah.
Because 4 just gave me tremendous problems.
You're good.
I looked at 4 and I tried to solve 4 and I could not solve it. And after like 15 minutes I noticed that's a diameter line.
Really?
Well, notice how the center of the circle is almost typoed out. It's like somebody erased it.
It is, yeah.
But I finally figured out that that was a diameter line, and now you can solve the problem. If you don't know that that is a diameter line, this thing is devilish. I don't think it can be solved.
I don't think it can either,
No.
yeah.
But if you notice that's a diameter line, and that's 76, well, this part has to be 104.
Okay.
And once you figure out what D is, now you know what this arc is. And once you figure out that arc, you can figure out what E is.
Okay, cool.
So 4 was some kind of problem.
For sure.
Only because when they printed it up, they covered up the fact that that was a diameter.
They did.
Which is really critical.
Interesting.
Okay, number 5.
Okay.
What do you know about quadrilaterals inscribed inside of a circle? What properties do they have that I just discovered like a week ago?
Sure. So we know that all 4 sides have to add up to 360.
Okay, what else?
And that isn't it 2 sides?
Very important quality that is not obvious from looking at it or anything else.
2 sides have to be, is it adjacent to each other?
No. Opposite angles are supplementary.
Opposite, okay.
Now, why? Because notice that the arc that is intercepted by this 76-degree angle is from here to here.
Okay.
And the arc that is intercepted by its opposite angle is the other half of the circle.
Okay.
Right? So those two have to add to 360, the 2 arc measurement, which means that the 76-degree angle and this angle have to add to 180.
That makes sense. So you just do 180 minus 76?
Yeah. So that's 104.
Okay.
Okay. Cool. What's T?
So we know that F is
like an F, I guess.
Yeah, so we know, so if I can't talk today, I'm sorry. But so if we know that's 104, we would just add them all together. So we would do 104 plus 90.
Just do the fact that these two are supplementary. You know that opposite angles of a quadrilateral are going to be supplementary if it's inscribed in a circle.
Okay, so 180.
Well, so what's that
Or
make
90,
that angle?
Be 90. 90 right there. Yeah.
Chewing on my putting green.
Cool.
Okay. So now we have to figure out G.
Okay.
Well, All right. These are tough. These are very thought-provoking questions. This may be some of the hardest stuff you've had this year.
It is pretty difficult, yeah. That was a perfect circle. Man.
I can barely draw a straight line, and yet draw
I can't either.
So that's 90. That's 90. That's 76.
And then 104.
11. And when they label it like that, it means from this point to this point.
Okay,
Okay?
Yeah.
That's the only thing it can mean. There's no other meaning that could be attached to that 111.
Okay.
And they're asking about that.
Okay.
Can you measure all of the arcs in the circumference except G?
I think you
If
can,
you
yeah.
can, then you can subtract them all from 360 to come up with G.
Okay. Okay.
It's this arc right here.
On 180.
No? What angle intercepts that arc?
76.
Okay, so what is that arc?
So we know that is, well, 76 times 2.
Right, they're either half or double, right? Everything
Right.
with
Yeah.
circles and all of this. And
Right.
it's clearly not half, it's not 38 degrees, so it's got to be double.
Uh-huh.
152.
Okay.
Okay, now that's everything except G, is it not?
Yeah. Yeah. So we would just add 152 plus 111 and subtract that from 360.
Mm-hmm.
So 152 plus 111 is 253.
263.
263, my bad. So 360 minus 263 is...
Let me tell you an easy way to do that.
Sure.
360 minus 260 is what?
100.
How many degrees is this less than 1?
Oh, 3 degrees less, so it'd just be 97.
That's the way you do it in your head.
Cool. Okay.
Okay?
Awesome.
All right, so let's look at 6.
Okay.
Six is no easy problem either.
Oh, no.
These are
It
brutal.
really isn't.
They are. I've never had such geometry problems from you that were this hard.
Are these like trig or...
Part of that is that this is not geometry that they expect you to know for the ACT or the SAT.
Mm-hmm.
So I don't end up reviewing this that often.
Right. Yeah.
But, unfortunately, you still have this chapter on circles that they're going to test you on in geometry. So, here, let's talk about another rule first, because this is an important one. In other words, all of this stuff is memory.
For sure.
It is. You just have to memorize the relationships.
Yeah.
What's the relationship between that angle X and the arc lengths AB and DC?
So we know that X is half of the arc length AB.
No. It's actually half of the difference.
Oh, half of the difference.
Yeah, it's the big arc minus the little arc.
Okay.
Okay, so that's the key thing to memorize.
Okay.
When you have two secant lines, that's a secant line, that's a secant line.
Mm-hmm.
When you have two of them that intersect outside of the circle, then this angle is half of the difference between that arc and that arc, the two arcs that are intercepted.
Okay.
Okay? Now, notice that problem number 6 is not exactly like this, but close enough that what if it was like this? That would be my two secant lines, right? So 50 would be this arc, 1/2 of this big arc minus this arc right there.
Okay.
Okay, so that's the key formula to remember. However, in our problem here, this is actually tangent. Well, notice that no matter how close I draw that, now, what is 50 degrees equal to?
Just 100, because it's
Now,
double.
hold on. It's half of what?
So it's half of AB and then DC, minus DC.
It's 1/2 of AB minus CB.
Or CD, yeah.
Okay? Now, they've labeled this part H. And the fact is that line does go through the center of the circle. So if I extend it like I have here, then 50 is equal to 1/2 of AB minus CB, and the fact that it's a tangent line instead of a secant line doesn't really matter. This angle, 50 degrees, intercepts two arcs. It intercepts AB and it intercepts CB.
Okay.
Now the fact that that's a diameter line means what? If this is H, what's AB?
So if that's H, then AB would have to be 50 is equal to 1/2. So just be...
What's the total distance from here to here? What's that arc measurement?
ABC 1...
Say it. You want to say it? I know you do.
150, right?
180.
180, okay.
It's half of a circle, right? Whenever you have a diameter line, you have half of a circle.
Okay.
So any arc is going to be half of 360. So that whole thing is going to be 180. Okay?
Okay.
And if they've called that piece H, what is this piece called?
Then that would be 180 minus H.
Yeah.
Yeah.
So there's your formula. You have the big arc, which is AB, which is 180 minus H. And you have the little arc, which is CB, which is just H. But notice what I get. I get one equation and one variable only, which means I can solve for it. Now, let's do so, because this algebra is not that trivial. So what's the first thing I want to do here?
Get rid of the parentheses.
Okay, that's fine. I would get rid of the denominator first, but
yeah.
What do I have to do to get rid of the denominator?
Multiply each side by 2.
Okay. Now, doesn't this look a lot simpler?
For sure.
So, to me, getting rid of denominators is almost just as good as getting rid of parentheses. But if you got rid of the parentheses first, you would have to distribute that 1/2 to all of these terms. Whereas by getting rid of the denominator first, I don't have to do that. Now, I just have to get rid of the parentheses.
Okay.
So, we don't need the leading parentheses. You never do.
Right.
I can get rid of those by just erasing them, because it doesn't matter unless there's a negative sign in front of the leading parentheses, and there wasn't here. So what does that simplify to?
Would that just be 180 minus H squared?
Not H squared. I'm subtracting one apple from another apple.
So just 0.
Well, I put that wrong, unfortunately. I'm subtracting a negative apple. I'm subtracting a positive apple from a negative apple. In other words, I have minus H minus H. There's the subtraction sign. Change it to an addition problem.
So negative 2h.
Yeah. Minus
Cool.
2h.
There
Now
we go.
we're getting simpler and simpler. Move the 180 over if you like. So I have minus 80 equals minus 2h.
H is equal to 40.
Yep.
Cool.
And notice I didn't put a whole lot of effort into making sure the coefficients were positive. In other words, I could have moved the 100 to there, making it 80, and I could have moved the minus 2h to the other side, making it plus 2h. Yeah, it wasn't worth doing both steps when I was able to accomplish one step. Do this. Since I have negatives on both sides, it's not that complicated.
Right.
To come up with h.
Cool.
But that was a tough problem.
That was.
Because you have to recognize, first of all, that this line has to be extended to make it a full diameter line. And then you have to know that the arc length of that half is 180, which makes that h and that 180 minus h. That's the only way to turn the problem into a single variable problem.
Okay.
And you can't really solve it without that. But
no. Yeah.
What's k here?
Okay. So the top is, so we know that this is an isosceles triangle because their two sides are equal or congruent to each other.
Let's just start seeing what it is we can figure out about this picture and see where that leads us. So if that's equal to that, what else is true?
So if that's equal to that, then it'd have to be...
What's true about isosceles triangles? It's not just that two sides are equal. What else is true?
Two angle measurements are equal.
Yeah. The opposite angles of the two sides are equal also. That's just as important as remembering that the two sides are equal. That their opposite angles are equal.
Yeah.
Well,
so they'd both be 75.
This angle, well, this angle subtends this arc, and this angle on the left subtends that arc.
Yeah.
So those two arc lengths have to be equal also. What's this arc length down here?
That would have to be, well, 30, or no, 60, because you just double it. Yeah.
Now, if this one is equal to that one, what is each one of them?
Then they both have to be 30.
Think for answering.
Wait, 180 minus 60.
No, hold on. What's the circle have to be?
360.
Okay.
So 360 minus 60 divided by 2.
There you go.
Okay. So 360 minus, so 300 divided by 2 is 150.
Both of them are 150.
Cool.
Now, your first answer was 30.
Yeah.
Always look to see if that makes sense. You can look at that arc right there and see, gosh, that's almost half a circle.
That's obviously not 30.
There's no way it's going to be 30 degrees.
Right.
And that's what I call a ballpark check. Your first answer did not pass the ballpark check. You must have done something wrong. Let's go back and re-examine it. Okay?
Cool.
All right. Let's go to number 8.
Okay.
Let me think here. Okay. Dog's reacting to what she hears.
Yeah. Yeah, my dog doesn't listen too well. She just sits in her yard listening to the river and then completely oblivious to what we're saying to her.
What is this measurement from there to there? The arc length.
Yeah, 180, because it's
Good,
half a circle.
good, good.
Cool.
Which makes the measurement from here to here what?
180 as well.
Okay, so that's 180.
Mm-hmm.
And they're telling us that's 41, which makes this measure from here to here what?
If that's 41, 98. Well, no, because
Supplemental to 180, right?
So 180 minus 41.
Yeah.
Which is 139.
Okay.
Cool.
That's M.
Uh-huh.
We solved for M.
Cool.
Now we got to solve for N.
Mm-hmm.
Let me think about this for a second.
Yeah.
Well,
we know the other side's 90 degrees as well.
Well, that's 98. We know it's 180 from here to here. So what is this measurement from here to here?
90.
Supplemental to 98. How much is it?
Or 98. Yeah, so it'd be 82.
Okay. So that's 82. Let me erase some of this stuff because it's kind of away.
Cool.
Okay, so far we have that's 98, that's 82.
Right.
And we're trying to solve for N. What's the measurement of the arc that N, call it either subtends or intersects? I think your geometry teacher refers to it as intercepts or intersects.
I believe so, yeah.
I say subtend, they mean the same thing. In other words, what is the measurement from here to there? Because that is what angle N intersects.
Has to be. Okay. So you'd have to do 139 plus 82 and then
what is that?
subtract that from 360. That would be...
Hold on. Add those two. What do you get?
So you get 132 plus... 139
plus 82 is 21.
Yep, 221 and then 360 minus...
Hold on. Stop for a moment. We're talking about an inscribed angle.
So you just divide that by 2.
An arc that is 221 degrees.
Okay.
But what is that angle?
So you just do 221 divided by 2?
Yes. You don't, it's not 360 minus that. In other words,
okay.
This would be 360 minus that. That's not what it's asking for. It's asking for angle M. Excuse me. And N intersects an arc that's 221, so N is 110.5 degrees.
Okay.
And that's a right angle, makes this angle here 69.5 degrees.
Yeah.
Because these two are supplementary because they're opposite angles.
Cool.
All right.
Okay.
9.
Oh, man.
Well, I haven't looked at it yet. I don't suspect they're going to get any easier, though.
I doubt it.
I briefly looked at it.
Yeah.
It's the first thing you kind of notice with this problem.
Well,
first of all, AB is parallel to CD.
You're right,
and the diagram doesn't show that.
And then AD is perpendicular to CB.
Hold on. None of those lines are transversals.
No.
How do we know that?
It's now 90 degrees.
No, hold on. Notice that that's parallel to that. But if that was a straight line, let's say that was a straight line, then that angle would have to be the same as that angle, right?
Right.
But they say that that angle is 121 and this angle is 97, which means those can't be straight lines.
No.
However, they do go through the center. So let's draw our picture properly.
Okay.
It's 121. This one's 97, and that alone, now that's equal to that because all radiuses are equal. In fact, the fact that those two lines are equal tells you that that's the center of the circle. And it also means that these two are equal.
Right.
Now, let me label this. P being the measurement of that arc between A and C, I guess.
Yeah.
It says AB is parallel to CD, but not like normally if you look at a picture like this and you see the two parallel lines, you have a transversal going between them.
Yeah.
But a transversal is required for it to be a straight line, and there are no straight lines crossing through that diameter.
No.
However, the fact that each of these is an isosceles triangle, what's this angle and this angle?
Would you just do 180 minus 121 divided by 2?
Yep.
So that would be...
I would prefer you to say that with confidence instead of...
Right.
No, I know that that seems like a very subtle point, but the fact is you did know that, and if you were to state it, it would be better. It reinforces your knowledge. If you were to say each of those angles is 180 minus 121, if you're wrong, I will tell you so.
Okay.
Okay? Yeah. So I would actually, even if you're not 100% sure, I would prefer hearing each of those angles is 180 minus 121 divided by 2.
Sure. So it would be...
Yes, that's correct. I'm not going to question it. We're going to go on. But it reinforces it in your brain rather than there's always that lurking suspicion. Is that what it is? That's what I'm trying to eliminate.
Okay.
So what's 180 minus 121?
159, and then...
Just 59.
Or just 59, and so it'd be 59 divided by 2 is...
What's 60 divided by 2?
25.
30.
So it'd be 29 and a half.
Exactly.
Yeah. Cool.
Same thing down in the bottom triangle. It's an isosceles triangle. What are each of these side angles equal to?
So it'd be 83 divided by 2, which is 43 and a half.
41 and a half.
Or 41, yeah.
All right. Now, what's arc BD?
Oh, that was Q, my bad. Hold on here. So angle, which one? I'm sorry.
BD. Now we know all the angles that we're going to know. Well, not quite, actually. We also know this angle. What's that angle there? No, we don't. No, we don't. Yeah. Remember, these are not straight lines. I accidentally drew them to look like straight lines.
Yeah,
but if they're not straight lines, we cannot figure out these two angles. In other words, this is not a linear pair. Okay? However, we can figure out arc BD, as in boy dog. Because this angle intercepts that arc.
Right.
What's that arc length? What's the measurement? I'm sorry, I didn't mean to say arc length. I meant what's the measurement of that arc?
Of BD would be 90.
What's its relationship to that angle?
It's doubled, so it would be 82, just 82. Or 83, my bad.
83.
Right.
Okay.
Yeah.
Now, the ultimate question is they want P.
Uh-huh.
Well, we're going to figure out P by figuring out all the others.
Okay.
Actually, we can figure out P right away. We have this angle down here. What's P?
Yeah. Also 83.
Yeah.
Yeah.
So now they want Q. Well,
Which was the angle.
Q. We're done.
Cool.
Now,
that wasn't as bad.
Well, here's the funny thing.
Mm-hmm.
The fact that those two lines are parallel
Mm-hmm.
had nothing to do with anything, did it?
I don't think so.
I never used that.
Yeah.
No. Everything was based on both of these triangles being isosceles triangles.
Yeah.
And that meant that these were each 41 and a half. And once you knew, in fact, you didn't even need to solve the top triangle.
No.
The only triangle you needed to solve was the bottom triangle, and that gave us P and Q.
Huh.
Which always leaves me a little suspicious. Why did they tell us those two were parallel?
Yeah.
Didn't really have anything to do with anything, unless I'm missing something. And kind of the way I think about this is, imagine that that's on a nail.
Mm-hmm.
And you can rotate this triangle or this triangle.
Right.
And that makes these two lines not straight lines.
Uh-huh.
Yeah, I'm not sure what that does. But I'm quite confident that we did it properly.
Yeah, me too.
All right. So
Cool.
the last one here, number 10.
Okay. Oh, well, that's just an inscribed angle, y right there. So it'd just be half of 68, wouldn't it?
Let me number some angles here.
Okay.
Which angle is half of 68?
Angle 1.
Yeah, very good. Oh, no. No, angle 1 is not an inscribed angle. Remember what an inscribed angle is. The vertex of the angle has to be on the circumference.
True.
So which angle?
So angle 2 would be...
Oh,
on the circumference?
yeah. How about angle 3?
Yeah, angle 3
Remember, first of all, the first rule is the inscribed angle has to be on the circumference. There it is. There's the vertex of that angle. It's on the circumference. Yeah. Secondly, the two rays that make up the angle intercept the arc that we're talking about. Mm-hmm. So what is angle 3 equal to?
34.
What's angle 4 equal to?
Angle 4 would also be 34.
What arc?
Oh, 78. Yes. So it'd be 38. Yeah. 39, my bad.
Now we can figure out angle 2.
Yeah.
Once we figure out angle 2, we can figure out angle 1, which is what they want.
Mm-hmm.
It's angle 2.
So 74.
73 is what those total.
There's 73, yeah. So that'd be 73. And then we know that y is linear to 73.
Yes, that's true. But let's figure out one thing at a time. Actually, you hit upon something. Mm-hmm. That's an exterior angle. What does the exterior angle say? theorem say?
Um,
What is angle 1 equal to?
90 degrees.
No, it's equal to the sum of the two angles that it is not linear with.
Oh, okay.
So it's equal to 73 degrees.
Cool.
In other words, if I have a triangle like this,
Mm-hmm.
and I say this is 101 degrees, that exterior angle,
Uh-huh.
what that tells me is that angle 1 and angle 2 sum to 101 degrees.
Interesting.
Why? Because 101 degrees is supplemental to x, correct?
Mm-hmm.
Well, the sum of 1 and 2 are also supplemental to x.
Mm-hmm.
In other words, all three of these triangles, all three of these angles have to add to 180. So if I add 1 and 2, well, they're supplemental to x.
Okay.
Well, if 1 and 2 are supplemental to x, and if 101 is supplemental to x, then 101 is equal to 1 plus 2.
Cool.
So 1 is 73 degrees, and notice that that really saves 2 steps.
Yeah.
Because we had to figure out that that was 107 degrees, doing it the hard way. And once we figure out that that's 107, now we know this is linear to that, so it's 73.
Right.
So you save at least one full step by knowing your exterior angle theorem.
Cool.
This one right there.
Awesome.
Wow, those were some kind of problems.
Yeah.
Here's all this stuff on the right here, over here, 1 through 10. Oh, that's just a place to put your answers?
Oh, yep. That was just where to put the...
Is this one of those things where he gives a little puzzle and
Mm-hmm. Basically,
the
yeah.
answers all spell out something, or I don't.
Oh,
No, maybe,
not this one.
no, not this one. No, he's just answering straight questions.
Yeah.
All right.
Awesome.
So is that it for tonight, Dylan?
Yeah, that's all I have for it. That was all my homework, so.
Yeah, we can call it a session. That's fine. Yeah, these were toughies, but you're probably going to be quizzed on this material.
Probably, yeah.
To say you can forget it 2 weeks from now, and guess what? You can.
Right.
You're never going to be quizzed on it again unless you become a math teacher.
Exactly. Which,
But unfortunately, you will be quizzed on it at least one more time.
uh-huh.
All of these things are still important.
Right. For sure. All right.
Okay, Dylan. I will talk to you next time.
That sounds good. Well, thank you, Mr. Cowan. I appreciate it.
You're welcome. Have a good
Awesome. All right, you too.